Hey everybody, I am back with another YouTube video. This time we are going to be working, or it'll be a little bit more about block design and matched pairs. Again, we talked about those both in class. We talked more about block design than matched pairs. So again, I'll talk a little bit more about both of those different designs in this video. So essentially what you'll see here is I have screenshotted or taken a picture of a few of the textbook problems, the even ones, so the ones that are not assigned for homework. And I just want to hit some key points on essentially experimental design, and then also spend some more time talking about writing out, like just write those templates that we've talked about in terms of how to design or how to describe an experiment. Because again, we have a test coming up, and I know that there are quite a few templates floating around at this point. So I just want to make sure we're on the same page. So in the first question here, I'm actually going to ask you to pause the video and read the question. I read the question, the video will be twice as long. But basically, there's a question involving acupuncture and whether or not it perhaps might help infertile women become pregnant. And so the first question asks, why did researchers randomly assign the subjects to the two treatments? We've seen this one before, right? This is what we started talking about back in the beginning of section chapter 4.2. So random assignment ensured that the two groups were as similar as possible before the treatments were administered. Again, the idea here is to balance out our confounding variables, right? We want to balance out confounding variables. For the second one, so it turns out that the difference in the percent of women who become pregnant in the two groups is statistically significant. Explain what this means to someone who knows little statistics. So I defined this term, it looks like on when we did completely randomized design the second day. And there was a homework question on it that was due today. But the idea here, right, is that the difference in pregnancy rates was greater than what we would expect from chance variation created by the random assignment to treatments. So again, the point here is that if it's statistically significant, the results are unlikely to have happened by chance. Okay, again, what percentage are we looking at? That's something that we need to build up to. And again, we'll focus on that in the second trimester. But again, just want to make sure we know what the definition is, so then we can build up to that over the next few units. And then part C, explain why the design of the study prevents us from concluding that acupuncture caused the difference in pregnancy rates. And so the reason for this is, if you take a look at the question closely, right, since the women knew the treatment they received, we don't know if their expectations or the treatments were the cause of the increase in pregnancy rates. So again, the point here is that maybe there was a placebo effect that is causing this increase. I think the real takeaway here is that it's not double blind. Okay, it's not a double blind experiment. Okay, it's not a double blind experiment. They did know the treatment that they were getting. If we scroll down to the next one, so again, I asked you to pause the video, read the question. Here, we are going to be comparing cancer treatments. So in this case, right, the first sentence tells us that the progress of a type of cancer differs in women and men. And so you would probably want to design a block experiment. And you could either focus on the different types of cancer therapies or the two sexes, right? That's the question in part A. The idea here is that we really want to control, we want to block by sex, right? And again, that's because the researchers believe that the progress of a type of cancer differs in women and men. So again, we're going to block by sex. So researchers will randomly assign all three therapies to each sex. Again, we want to make sure that we split men in male, female, right? And then the males are split into three groups, they get three treatments. The females are split into three groups and they get three treatments. And again, I'm going to talk a little bit more about how that works on the next slide. And again, what are the advantages of a randomized block design over a completely randomized design using these 800 subjects? So again, using a randomized block design allows us to account for the variability in response to the treatment due to differences in gender by comparing the results of the 3 treatments within each gender. Again, in a completely randomized design, the variability due to differences in gender is unaccounted for, making it harder to determine if there is a difference in the response to the 3 treatments. So this is actually the question that we answered at the end of the most recent class. And the real idea here, if I can summarize, is that we're trying to control sex as a confounding variable. And the hope is that this will lower variability. The hope is that this will lower variability. And ideally make it easier to determine cause and effect. And again, we started off chapter 4.2 by discussing the idea that, right, that random assignment ideally will balance out these confounding variables, but there are some confounding variables that we would like to be able to control further, especially in this case, because we know that the progress of a type of cancer differs in women. All right. So this next question, or it's not so much a question as a description of first a completely randomized design and then a block design. So again, I would ask that you pause the video here and make sure you write this down. Again, I think that this unit is a little more challenging. I was talking to someone today about how to study for the next test. And I said you might almost want to make a flashcard where you have the template and you write, assign each subject a unique number between blank and blank, right? That would be your first sentence. You can fill in the numbers from there. So again, for a completely randomized design, we want to assign each subject a unique number between 1 and 800. And then use a random number generator to choose 267 numbers between 1 and 800. The idea here is that there's 3 treatments, 800 people. So this is approximately 1/3 of 800. Again, I think it'll be like 267, 266, which I think is going to be okay in the long run. So we choose 267 numbers. We ignore repeats. Subjects assigned the chosen number will receive treatment 1. Then we choose another 267 unique numbers. Again, unique numbers that were not chosen above, ignoring repeats. Those subjects are assigned the chosen numbers. Those subjects receive treatment 2, and then the remaining 266 subjects get treatment 3. After administering treatments for a sufficient amount of time, we compare our results. Okay, so that is the template that you're looking for in a completely randomized design. So again, we have our labeling, right? Then we have our randomization, and then we have our assignment. Okay, those were the 3 steps that I talked about in class. Again, the goal here in these descriptions is to be so specific so that someone who had no statistical background could follow what you're trying to do. For the block design, again, this is what we just talked about. So we're gonna block by sex, right? And so what you're gonna notice here is that essentially after we block by sex, then it's going to be, we're gonna do 2 separate, completely randomized designs. So you do kind of have to repeat yourself. The numbers will change a little bit based off of the populations. And then at the end, we compare results within each gender and then compare results across gender. So again, I'll read through the male one, which again will look very similar to the completely randomized design, because this portion after we've blocked is just a completely randomized design. So again, we assign each male number a unique number between 1 and 500, using a random number generator to select 167 numbers. I think if you look back, yeah, I guess there were 500 males. So 167 is 1/3 of 500. Again, we ignore repeats. Those subjects get treatment 1. Then we choose another 167 unique numbers. that were not chosen above, we ignore repeats. The subjects assigned the chosen numbers receive treatment 2. The remaining ones get treatment 3. And then the same one, we do the exact same thing with the females, except for there's 300 numbers. So it's 100, 100. Okay. So again, if you're, I actually think that these are not quite as difficult if you think about the outlines that we've done, right? That is essentially what the outline says. This is just telling us a little bit more about how we put the people in the groups. All right, so again, if you want to use the picture of the block design to help you along the way, I think that would be helpful. And then again, after we've described we described the blocking, we described the 2 separate completely randomized designs, and then the final one, again, this is where the arrows come together for the males, the arrows come together for the females, and then the arrows come together for both of the groups. We want to compare results within each gender and then compare results across gender. And then finally here, somebody, and again, pause the video, write the question down. The BYU Stats Department is performing experiments to compare teaching methods. They're curious to know if the standard overhead projector in chalk is better or worse than multimedia. So in this case, we have 8 lecture sections. And if you take a look here, there's 8 sections, but interesting enough, each professor teaches 2 classes. So Hilton is section 1 and section 6. So for part A, suppose we randomly assign 2 lectures to use standard technology in their sections and the other 2 lectures to use multimedia technology. Explain how this could lead to confounding. So the problem here, right, is that if there is a difference in response between the 2 treatment groups, we will not know if the difference is a result of the technology used or the instructor. If there's a difference, right, we essentially won't know what the cause is. And so, and so the point here is, again, this is something that we'd really like to control in order to reduce variability. And so a better design for this experiment would be a matched pairs design. So I'm gonna, I realize I didn't take a screenshot of what I wanted, so give me a couple seconds here. Let's see. 1 second, there's always something that goes wrong. If I didn't have to teach my softwares in a few minutes, I would have cleaned it up, but I'm also not sure how to record the rest of it. So let's see. All right, there we go. Sorry, I have too many tabs. Okay, so here we go. So again, like I said, we're going to use a matched pairs design. So again, we want to make sure that we are focused on the technology, right, not necessarily the teacher. So we're going to do something that I mentioned in class. We're actually going to treat each teacher as a separate block. Okay, so this is where you are a block on your own, and again, you get both treatments. And so we randomly assign one of each teacher's sections to each of the 2 methods. Again, as I said in class, we do have to make sure that in matched pairs, right, who gets which one is random. The example I gave certainly was timing, right? So for drugs, does the placebo versus the treatment, right, and the treatment versus the placebo, right, the timing might matter here. In this case, maybe one of the courses is stronger than the other course. So we want to randomly assign one of each teacher's sections to each of the 2 methods. One possible method for randomization is as follows. So each section already has a number associated with it, right? 1 through 8. And what we can do is we can randomize by using a random number generator to choose 1-digit numbers from 1 to 8, ignoring repeats, and letting the first section of each instructor that is selected to be taught using multimedia. So in that first, if my first number was 6, right? Section 6 with Hilton, that's going to get the multimedia, and then section 1 is going to get the standard overhead projectors and the chalk. And so again, the first section multimedia. This other section is standard. And then at the end of the semester, final exam scores and student attitudes can be compared. One last thing I want to say is that a match pair design is a block design. Okay. The blocks in this case are the pairs. So again, you would have I guess 4 blocks in this case, right? You'd have 4 blocks in this case because there's 8 total and 4 professors. Again, we did treat each teacher as a separate block and we made sure they got both of the treatments. So I think that's all I've got. Sorry about the slight technical interruption, and I will see you guys at our next class. Thank you. Bye.